All right, let's get to it. Question 1. What is the binary equivalent of 276 base 10? Okay, so we're going from 276 in a base 10 down to binary, and here are our options. Our first way we can do this, we have two ways we can solve this problem, is we can simply write down our place values across the top of our paper and then just figure out what we need and what we don't. Okay, so we can do that now. We can just go across and 1, 2, 4, 8, 16, 32, 64, 128, 256. I'll stop there because I know that I can get up to 276 with a combination of all of these. So I'm just going to simply separate these with a line. Forgive my wonderful drawing here for a moment. Okay. All right, so basically what we're going to do is we're just going to move our way down the list and figure out if we can use the number to help us make 276. So can 256 go into 276? Sure it can, okay? So we have that, so we just do some simple subtraction now. 276 minus 256, and if we just draw that out, that cancels, that cancels. Okay, so we're left with 20. Okay, so right away we know we have 20, so that's way too big. 128 is way too big. 64, way too big. 32, closer, but still too big. 16, yeah, 16 can go into 20. Remember, our rule is if you can put it inside, you must use it. So now we're down to 20 minus 16, which we know is 4, which means simply no, yes, no, no. Okay, so remember, every single check as we move across is a 0, is a 1, and every x is a 0. So what do we have here? We have 1, write that again, 1, 0, 0, 0, 1, 0, 1, 0, 0. Okay, so if we do that, 1, 0, 0, 0. So we have 1 and then 3 zeros and 1, 0, 1 and then 2 zeros. Okay, so let's check that with A. We have 1, 0, 0, 0, 1, 0, 0, 0. Okay, that matches. And then 1, 0, 1, 0. Nope, doesn't work. Okay, A, see you later. Goodbye, A. Okay, if we look at B here, we can know there's nothing in our answer here that has any sets of 3 1s. So see ya, B. Okay, C. This looks a little more promising. Let's look what we have. 0, 0, 0. Well, we can look at that right away and we can go 0, 0, 0 is equal to 0. So on C and D, we can just ignore those zeros at the beginning and we can just work with what we have here. So we have 1, 0, 0, 0. 1, 0, 0, 0. Ooh, looking good. 1, 0, 0, 0. 1, 0, 1. Nope. No, right here we have a problem, so no. So it's looking like it has to be D, but, you know, teachers can make mistakes too, so let's check this out. Does this work? 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, and then we left with 1, 0, 0. Yep, that matches up, so our answer is D. Our other way of solving this problem, of course, is once we start getting to bigger numbers like 276, our other option that we can start using is divide by 2. Just constantly divide our numbers by 2 until we get all the way down to 0. Okay, so 276 divided by 2 is equal to, what is that? That's 138 with a remainder of 0. Okay, now we're just going to divide 138 by 2. So 138 divided by 2 is equal to 69 with a remainder of 0. Okay, keep going. 69 divided by 2, that is equal to 34, remainder 1. Okay, so now we're got a 1 in there, so 34 divided by 2, that equals 17, remainder 0. 17 divided by 2, that equals 8, remainder 1. Now we're down to 8 divided by 2, and that is equal to 4, remainder 0. 4 divided by 2, that is equal to 2, remainder 0. 2 divided by 2, that equals 1, remainder 0. 1 divided by 2, that equals 0, remainder 1. And we stop when we get a quotient of equal to 0, so we stop. And then the trick here is we don't go from the top down to get our decimal number, we move this way from the bottom up. So our binary number here is 1 0 0 0 0 0 0 1 0 1 0 1 0 0 1 0 0, which is the same thing we got of here. So we got the same answer using both methods. Which method is right, which method is wrong, that's up to you to decide. Whatever works best for you, as long as you get the right answer so that you can circle D and get that 1 point. Okay, let's move on here to number 2. Okay, in number 2, we have, is there anything wrong with this code? We have system out print 3 plus 3. That's looking good so far. And then, oh, look at that. Right at the end, we can see right here at this first line here, something's missing. What's missing? The semicolon. We've learned that semicolon is the end of every single line of code, so that ends every statement. If we don't have a semicolon, the compiler will complain. So we know that's a compile time error. So if we look down here at our options, the first one, compile time error, that's looking pretty good. Okay, so I liken that, but we got to check everything. Runtime error, definitely not a runtime error. Programming error doesn't exist. We've never learned about programming errors. That's not even a thing. Okay, so it's definitely not C. And D, no error. No, there's definitely an error. There's a compile time error. So yeah, sure enough, our answer is number 2, A, compile time error. This won't compile. Okay, let's move on. Question 3. It says, what does the following code snippet produce? System out println, and oh my goodness, here we have a whole bunch of escape sequences. So remember, escape sequences, we're dealing with 3 kinds here that we need to know. It's the slash and then the end. Remember, that's new line. So wherever that appears, it'll print the next text on a new line. Slash slash, that just produces a slash. And slash quotations, that produces quotation marks. Okay, so these are the 3 we need to know. Okay, so remember, you can always think of them in sets of 2. Slash and then the code. Slash and then the code. Slash and then the code. So what do we have here? Okay, we have 2, so that is 1 slash, and then we have the next 2, so that's another slash, and then we have, oh, by itself we have quotations. That means the compiler will see the beginning of the text here and the end of the text here, so it'll see all of that as text, and then it'll wonder what is hello world. It will wonder what's going on here. Okay, so this, if we were typing this into our BlueJ IDE, we would have this as green, and then this would be black, and then this would be back to green again over here. So we'll be getting us all sorts of errors here. Okay, so this doesn't work. It's an error. Okay, it should be what's here, what's missing right here. It should be slash, right? It should be this, but it's missing. Okay, because we only have 4 slashes. We should have 5. Okay, so this is an error. Okay, this is a compile time error. The answer is B. This doesn't get printed, this doesn't get printed, this doesn't get printed. In fact, if we didn't have this error here, none of these would be correct. Okay, this can only be one thing: compile time error. Missing that slash. Okay, number 4. Number 4 is a question dealing with computer hardware. So which of the following describes the function of a computer's hard disk drive? So we're focusing on the hard disk drive. Okay, if we remember the hard disk drive, that is memory. So we're looking for keywords of memory, and hard disk drive, that's the memory that saves when the power is turned off. Okay, those are the key things we need to remember. So let's look at our options down here for A. It allows all of the computer's different components to communicate with each other. Note, that doesn't match anything we have here. In fact, that's the definition for the motherboard, or as we like to call it, the MOBO. So that's the motherboard's function. Okay, the next one, it's the main processor of the computer doing most of the computational work of the computer. Nope, that's not it. That's the CPU. Okay. And what else do we have here in C? So it's not A, it's not B, C. It is the form of memory. Oh, so we got memory here. Cool. Oh, and if we just glance down at D, it's also memory. So it looks like we're down to C and D. Let's keep going with C. It's a form of memory that stores data. Okay, thanks. That's what memory is. Anyways, so what do we have next? Even after the computer is turned off. Ooh, that's key right there. Turned off. What did I mention up here? It saves after it's turned off. So that's looking pretty good, but let's continue just to double check. D, it is a form of memory that is used while a program is running. Okay, running. However, when turned off, oh, there's turned off again, all the data it stores is lost. Ooh, so that is actually a definition of RAM, random access memory. So our answer here is C. It matches what we were thinking of up here when we first started hard disk drive. And we can see that we're basically choosing between C and D, but D, I should say, is RAM. Remember, RAM is used when the program is running. All of the programs and data get loaded into RAM because it's much faster than the hard disk drive. However, the downside of it is that all the RAM is erased once the computer is turned off, and all the data is saved in the hard drive if you have, in fact, saved it. Okay, let's move on to question 5. Ooh, question 5. It's a question of print and println, and see what's going on there. Okay, so what is the output of the following code snippet? Okay, so we have to look at these. What are our options? We're looking at 1 line, 2 lines, 1 line, and then error. So we got to even be checking to see if there's an error in this one. Okay, let's get to it. System out print. Okay, that seems okay. Hello. So I'm just going to write it up here to see what happens. So I'm going to write hello. That's what gets printed. Okay, and then we have print. So that means the next thing that gets printed is right here. It hasn't gone down to a new line. So then we have system out println, and then it says good day. Okay, and notice there's no space after the O or no space before the G. So what do we have is we have hello, good day with the space and exclamation point. So we have hello, good day, but there's no space here. This is the key point. There's no space. Okay, so let's look at A, hello, good day. Well, there is the space there, so no, see you later. Hello, and then new line, good day. That's what we do not have. We do not have a new line. It's all on one line. That would be the answer if this was a println, but it's not. So no, see you later, B. Okay, hello, good day. That matches what we have. That looks pretty good. And then let's just double check. No output due to compilation errors. Let's double check this. Semicolon, semicolon, quotation, quotations. Yeah, system out print, system out no spelling errors. So no, there's no errors. Answer C. Hello, good day without the space. Okay, let's move down to 6. Very similar question asking which one compiles without errors. So that means there could be some errors down here. And displays hello, good day on the line. So it's very similar to number 5, except it's going to correctly say hello, good day with the proper spacings. Okay, so let's see what we have here. System out print, hello, and then good day. In fact, this is very similar to what we have up here in 5. It's actually the exact same code. So we know what that prints. We just did it. So that outputs hello with no space, good day. And we know that doesn't match this, so we know right away, nope, can't be A. All right, B, system out print hello. Okay, so then we have B is saying hello. And then, oh, notice we have a space here. So we have a space, and then there's a print, so that means after a space, the cursor is still here. And then it says println good day. Okay, so then it's doing this, good day. That's looking pretty good. Okay, let's keep going. So let's give this one a smiley face. That's a good option so far, but let's keep going. System out print hello. Oh, we can stop right there. We're missing semicolons. So C, sorry. Goodbye, C. We got a compile time error right there. All right, D, system out println hello. Okay, that's no real error there. So we'll say hello. It's got the space, that's good, but notice it's println. So that means after it prints the space, we're down here on the next line, and then system out println good day, we have this, good day. And that doesn't match what we're looking for. So yeah, see you later, D. Our answer for number 6 is B. All right, let's move on to 7. 7 is asking us, is there anything wrong with this code? Okay, let's look at it. System out println, and then we got some math here. This might be a little confusing. We haven't studied any math yet or how to do it, but it's on the test, so it should be something we should be able to solve. And just from simple experience at your age, you should know that this is 6 divided by 3, so this is 2 minus 2, which is equal to 0. Okay, but I can tell you there's nothing wrong with this math the way it's typed up, so there's nothing there. Semicolons there, so I don't know what's going on. Oh, look at that very first line. System.out.println. The S is lowercase. That S needs to be capitalized. That my friends, is A, compile time error. We know that's not a runtime error because runtime errors happen as the program runs. Programming error, as we mentioned before, there's no such thing as a programming error. This thing definitely has an error, like a capital S, so it can't be D. So it's basically down to compile time or runtime. This won't run because we need a capital S there. Answer A, compile time error. Let's move on down to 8. What is the binary equivalent of AF09 in hexadecimal? So we're going from hexadecimal base 16 down to binary base 2. Okay, so this one we know. We always got to think of that trick. Always think of your answer in 4s. Break everything down into sets of 4. So let's do that. Let's do AF09, sorry, not 09. Okay, so we know it's a base 16 model, and we're going from 0 to 9, A to F, and A is 10, and F is 15. Okay, and we know right away that's 10. So we can do the binary equivalent of, right, so this is 10 in base 10. We need to do the binary equivalent of base 10, and that we know is 8 plus 2. So 8 plus 2 in our sets of 4 binary digits. Remember, the whole 4 trick is break everything down into sets of 4 binary digits. And those place values are 1, 2, 4, 8. So everything here can be made with a combination of these. So that's all we really have to do is take that A, which is 10, and turn it into a binary, which is 8 and 2. So that's 1, 0, 1, 0. Okay, so that's A. F is really simple. F is 15. F is always this, 1, 1, 1, 1, right? 8 plus 4 plus 2 plus 1. 8 plus 2, that's 10. Plus 4, that's 14. Plus 1, 15. So F is always 4 ones. 0, that's really simple. 0 is 0. 1, 2, 3, 4. Done. 9. 9 here is in the first place value, so we're just doing 9. What's the equivalent of 9? 9 is 8 and 1. So we're going to go 1, 0, 0, 1. And so those are our 4 place values. That's all we need to do. Of our AF09, that's our 4s. So we just need to look for the equivalent of this whole binary number here in our options. And the easiest way to do that is simply to draw a line. So I'm just going to choose a line here. Okay, and then come down here and just separate everything into sets of 4 to make my life easier, make it good for my eyes. And I suggest you do this for yourself as well if you're ever on a test, is just simply draw some quick lines on your test paper. We got 4 sets of 4 because we got 4 things here. And then we can just simply go down and see which one matches up with what we have. So our first one is 1, 0, 1, 0. 1, 0, 1, 0, that's working. 1, 0, 1, 1. Nope, right away, B, goodbye. 1, 0, 1, 0. Okay, that works. So A and C are working still. D, 0, 1. Nope, C or D. So right away, just by looking at the very first set here corresponding to A, there's only one match with A and C. F is 4 ones going across. We got 1, 2, 3, 4. Good. 1, 2, 1. Nope, doesn't match right there. Goodbye, C. A is my only answer. So you see how fast we did that? Once we knew what our pattern was, we just simply looked for what matched. And if we continue along, 0 is 0. Yep, that matches up. And 1, 0, 0, 1. Yep, sure enough, that's it. The other thing I could have looked at is once I did this, I have 4 1s and then 4 zeros. I could have quickly just gone over here and looked. Where do I have 4 1s and 4 zeros following each other? And nowhere. I only have it in A. So I could have just looked at that. I didn't even have to look at A or 9. I could have just go, oh, I know what F is. I know what 0 is. That's 4 and 1. And then start looking for patterns. It's all about trying to save yourself valuable seconds when you're doing these multiple choice questions. All right. So our answer for number 8 is A. Number 9, what do we got? Which of the following statements is valid with respect to the usage of a semicolon in Java? Okay, so we've got this semicolon in Java. Okay, let's read what we have. A, the semicolon is used to denote the end of a statement. Okay, denote, another word for denote is symbolize or signal. Signal the end of a statement. Well, I think that sounds pretty good. So I'm going to put a little smiley face. I like that one so far. Okay, a semicolon is used to terminate a block of code. How is that? That's very similar to A, but it is different. What B is talking about is once you start learning a little bit more about code, you're going to start thinking of code in like blocks of code or sections of code. And that's basically going from curly bracket to curly bracket. So you can think of the code that we've learned so far. We've learned about a main method. And where does the main method start? After you write the public static void main string args, where does it begin? It begins after the curly bracket and goes to the curly bracket, right? So that's like the main method block of code. And where does this sit? That sits inside of another block of code, which you can consider the class code, right? That goes from curly bracket. So there's another block of code. So once you start dealing and becoming more experienced with code and becoming more comfortable with stuff, you begin to think of things in terms of blocks, okay? But blocks are dealing with curly brackets, not with semicolons. So even though it looks like it could be a good answer, B is actually no. B is see you later. Sad face for B. Oh, I'm sorry, B. You put in a good try. C, the semicolon is used to terminate a class. So we just talked about that. That's this thing here. So no. C, what you trying to do to us? Okay, D, a semicolon is used to terminate a program. We haven't learned about terminating a program or how to do that. So no, that's just nonsense. The only answer we have that has a smiley face, A. Number 9, A. Okay, let's move on to D. In 10. Number 10, we're looking at some code and finding the errors in the code and circling them. And then once we have identified them, we have to indicate the type of error that we have down here. Okay, so let's get to it. So we have public class pizza. So far that looks good. Public is always lowercase p, class is the way it is, and our class begins with a capital, as we've learned. Classes always begin with a capital P, or a capital letter, I should say, so that's good. There's the curly bracket for the class, and let's move down. We can draw some dots here and look. Yep, there, sure enough, there's a partner for that bracket there, so that's good. Then our next line, public static. Well, right away we can see we have an error here. Static is spelled correctly. However, that's error number 1. That should be a lowercase s. So error number 1 down here, number 1 error, that kind of error is a compile time error. Okay, so that's a compile time error. The computer will look at this, or the compiler will look at that and go, I don't know what a static class is. It's going to look for a class called static and just stop because it doesn't know. So that's got to be a lowercase s. Okay, so let's keep going. So public static void, that's spelled correctly. Main, that's good. String's a class, capital S, good. We got our brackets, args, that's all right. We got our parentheses there, that's good. There is our curly bracket to begin the class, and let's see, is it lined up? Yep, there's the closing one, so our brackets are good. We have no problem with any of our curly brackets in this program. Let's see what's being printed out here. System.out.print, that's good so far. There's our opening parentheses. Do we have closing? Yes, we do. There are some quotations, closing quotations. Yeah, this so far looks pretty good. Let's go inside. I really enjoy eating pizza with my family with a period. That's not bad. Semicolon. So this line looks okay to me. Nothing so far. Okay. System out println. Okay. In fact, my daughter. Oh, right there. Daughter is spelled wrong. That should be an AU. So that's error number 2. And that's a runtime error because the compiler doesn't know what I'm trying to do here. It's not checking my spelling while the program's running. It's just printing out whatever I write. So that's error number 2, and that's just a simple spelling error. That's a runtime error. Okay. My daughter calls me. Okay. Oh, there we have an escape sequence, right? So that'll print out the quotation mark, the pizza monster. And then we have our next closing bracket, right? That works. So that'll print out the pizza monster. That's good. Semicolon, that's good. We have parentheses, that's good. So what's in fact missing? Well, let's look at this right here. We have a quotation. And then do we have a closing quotation? No, in fact, right here, right after this quotation, we should have another set of quotations. So that's error number 3. We're missing some quotations, and that's in fact a compile time error. So I'm just going to write that in. Again, forgive my messy writing. Compile time error. So we've got one compile time error here with static being capitalized when it shouldn't be. We have a second error here, runtime, where daughter is spelled incorrectly. And then here we have error number 3, where the quotations at the end of the line are missing. So that's a compile time error. 3 errors. If I was grading this on a test, as you can see, this whole question would be worth 3 points. And each one, that would be 0.5, that would be 0.5, that would be 0.5. So simply circling them would give you 0.5. And then each one of these would also give you 0.5 for indicating the type of error that you had. So altogether, this question would be worth 3. All right, let's move down. Question 11, what do we have here? When you compile a Java program, what are you doing? Okay, what do we have? So remember, compile. Java is a compiled language, meaning we write some code in English-like high-level languages, and the compiler compiles that code down for the Java virtual machine. Okay, and bytecode. So let's look at this. What is A? Saving it to disk. No, that has nothing to do with saving our program. If we want to save our program, we just simply hit File Save As or File Save. Okay, so no, can't be B. Can't be A, sorry. B. Converting it into a form the computer can better understand. Okay, so that's converting, so right? So that's kind of like translation. So that's kind of what I just mentioned. That sounds pretty good. Let's see what we have for C. Adding it to your program collection. No, that's not how you add things to a collection of programs. I don't even know what we're referring to here by collection of programs. Is this like all the programs you've made and they're collected on your computer? Is this a package, or I don't know what's going on here. So no, can't be C. Our only logical answer here is B, in fact. Okay, and that's the whole job of the compiler. The job of the compiler is to take our English-like instructions, compile them down to the lower level language, and in Java's case, it's compiling it down to the JVM, the Java Virtual Machine. And in fact, that leads us to question 12. Explain the difference between bytecode and source code. Okay, so in order to get your 2 points for this question, you would have to define what source code is, and you'd have to define what bytecode is. So what is source code? Source code, that's the code that the programmer is writing. So the source code, that's the code you're writing in Java in terms of the main method, system out, println, all the stuff you're writing in our BlueJ interface. That's the source code. So stuff like public, static, void, main, all of that code that we've been learning to write in BlueJ, that's source code, right? That's written by the programmer. Okay? However, we've learned that the computer hardware, namely the CPU, it doesn't work in this world of English-like instructions. It's still down in the machine language of binary. So every programming language needs some way to translate the source code down into the machine code of the CPU. And what Java does, Java is a compiled language, so Java has a compiler, right? And the compiler's job is basically take our source code, the compiler compiles it down, and in the case of Java, it compiles it down into what's called bytecode. And bytecode is the code for the Java virtual machine. Okay, remember we've learned that the Java virtual machine, it kind of sits between your source code and the CPU of the computer that's running the Java. And what the Java virtual machine is it sits and floats in kind of like a virtual world on the CPU, and therefore it allows it to work on multiple different operating system CPUs, such as Linux or Windows or Mac. Okay, so what we're looking for here for the answer is we're looking for that the source code is the English-like instructions written by the programmer, and the bytecode is the compiled language for the JVM, the Java Virtual Machine, so that it can further compile it down to language for the CPU. Okay, because that's what the JVM does. It compiles it, interprets it, and puts it all together for the CPU. We don't really care how all of this happens. What we do need to know is that we are writing in source code. There's a compiler in the background that needs to compile our code, and what it's doing is it's translating it into the language called bytecode, okay, for the JVM. So the bytecode is the language for the JVM, and then the JVM further interprets it for the different CPUs that it's running on. If you explained that in some way, shape, or form, you would get your 2 points. You basically needed to point out that source code is the high-level English language that we've been writing, and it's done by the programmer. And you need to indicate that the bytecode is produced by the compiler for the Java virtual machine. Those would be the things I would be looking for if I was grading this. You'd have to mention a compiler compiling the source code into bytecode for the Java virtual machine. Okay, and if you did that, you would get those wonderful 2 points. All right, so this has been a review of your formative assessment, just to give you an idea of how the test will run and the kind of questions you'll be facing on this first unit test. If you have any further questions, by all means, come see me in my room before the test or send me an email. Good luck studying, and see you in the halls.